Welcome everyone to another Dolphin Communication Project Deep Dive webinar. Today we are joined by Dr. Heather Hill, a DCP favorite. She's stuck with DCP forever, I think, Heather. There's no leaving us.
Nope, nope.
She is a professor at St. Mary's University in Texas, and she's been studying behavior and cognition of cetaceans and pinnipeds for 25-ish years. Not sure which side of the 25 you're on at the moment. But she is
Over
very
now.
busy, and we are delighted to have your time, your expertise, and your enthusiasm this evening. So with that, I'm just going to remind those folks who are listening live to please use the chat function to submit your questions. You can submit those questions to everyone or just to DCP, and we'll see them, and we will get to those questions at the end of Dr. Hill's talk. So with that, I pass it to you.
Excellent. Well, thank you very much, Kel. It's my pleasure to be able to be here for part of it again. Yeah, I'll get there a second. And to share some of what we have been working on for the last few years. Should I do just that screen? Okay, yes. This is always the fun part when you go to a new computer. Which thing do you show up? Yep, we got it. So we've been working with creativity under control by the trainers for a while now. Probably, I guess, since 2017, we got it going again in a couple of different facilities. And so what we had the pleasure to do was kind of get it started with some bottlenose dolphins, and then we were able to move it on to some killer whales. And then we finally finished the bottlenose dolphins. So my goal tonight really is to kind of share a little bit about the findings of what we did with both of those species of dolphins, and then hopefully kind of expand it into perhaps us better understanding how they can use creativity in their natural habitat and ways that we might be looking at it from this sort of setting. So hopefully we have a little fun tonight. Ask your questions. I'd love to have conversations about all of this stuff because there's no right answer, but we're going to share a little bit as we go. So these are all of my colleagues that have helped to pull it all together and get us to where we are today. So hopefully this makes sense. When we think about creativity coming to whether it's humans or animals, there's a lot of different ways that we think of it. It can be what we typically think, which might be the forms of divergent creativity, where you are looking for novel solutions or coming up with amazing works of art, or something that's truly out of this world and extraordinary, and not a lot of individuals are able to do it. But then we can also think about creativity from the idea of which we're kind of looking at the same pieces of information, but maybe perhaps you pull out a different solution, or you come up with a similar solution. So something we call more of a convergent form of creativity. But when we think about humans versus animals, sometimes we may become a little challenged in trying to figure out how do you define creative? What is unusual? What is different? What is rare for animals in their natural habitat, but also in certain situations? So there you have a picture of the bowerbird kind of decorating the bower, which could kind of fall under a definition of creativity. Some bowers are more prettily decorated than other bowers, and then the females decide which ones are more attractive, and those are the ones that they mate with the males for. And then you have on the other side of the house the elephant that is painting. And is this painting something that we would truly consider creative if it was being reinforced by a human trainer, or if the animal was doing it sort of on their own? And so those are some of the questions that we have when we start looking at creativity from different species. Now, in humans, we have particular standardized tests that are often given, and many of those tests are kind of either written forms or pictures that require a visual stimulus that you then decorate from an artistic point of view, like a lot of us are more familiar with. And then those standardized prompts, the individuals who are taking these tests have opportunities to do, several trials on them, and then outside people kind of come in and then they rate those responses or their pictures or the types of information they may provide in their responses to these standardized tests on these 4 categories. So the Torrance test of creative thinking is one of the sort of top of the line creativity tests that's been around for a long time. It pulls in a lot of elements to it. And the responses for humans are often evaluated for how many different kinds of responses are produced or how unique the response is. And then in other arenas, it might be more like how many different categories are represented by the standardized responses that the individuals have put together in their most creative ways. And then finally, how many details are presented within that. So back in 2004, Kaufman and Kaufman just thought that maybe it would be a good idea to take advantage of these 4 constructs that are typically measured in humans and see if they could be applied to animal behaviors that could be considered potentially creative. We knew at that particular time that the ability of creative thinking had been explored by a number of different trainers that began with Karen Pryor back in the 60s, where she was working with a couple of rough-toothed dolphins and trying to get them to perform new behaviors, different behaviors that they had never performed before. And so she decided to try to do what we call either innovate or create and put this idea of, can we encourage animals who we can't communicate with verbally? We can't say, hey, do something you've never done before. With our words, we have to do it with our actions and our feedback, our consequences of positive reinforcement or no reinforcement. So with that information, the animals had to kind of figure out what the light bulb was, where the epiphany was. What is it that my trainer's trying to get me to do? And when she implemented this kind of feedback or these, contingencies of positive reinforcement and no reinforcement when they produce different behaviors, she was able to teach the animals through conditioning, hey, we want you to do something you've never done before. And she was fairly successful with it. She was able to get the animals to produce truly novel behaviors that they hadn't seen before, produced before, or been taught to do before. So at this point in the game of 60s and 70s, it really was, can you use reinforcement to teach individuals how to be creative? So we knew that humans were able to do this. We know that we can increase creative responses. We can increase novel responses. We can increase the number of solutions that individuals do on a standardized test by using reinforcement. We also know that in humans, you can remove that creativity, remove that innovation, that fluency by removing the reinforcement. So we do know that having operant conditioning involved can increase those sorts of responses. So that was kind of sort of the working operation that we were kind of applying to the animal side of the house. So Karen Pryor demonstrated this in rough-toothed dolphins, and then other folks, other labs, other groups wanted to start working with this notion of, well, what does it mean when you are trying to train an animal to be creative and put it under what we call stimulus control, when they know when they see a particular hand gesture that they are supposed to do something they've never done before. And that's where Mercado and Lou Herman and Stan Kuchai and Holly Eskelin kind of came into the mix of trying to study this behavior, this idea, this construct of creativity in animals in a more standardized form. And so with that, it came with a couple of variations. And these are important variations because it wasn't just about producing only novel behaviors. They needed to just produce different behaviors. Because when you ask for individuals to produce truly novel behaviors they've never produced before, we have to know a lot of information. We have to know how much they know. We have to know what behaviors they have before. But we also have to hope that they can put something together in a unique and different way than they've ever done before. And sometimes that's hard to come up with. And those of us who aren't as creative as others may already feel that. So in the later studies that you see there, it didn't have to be truly novel. It could simply just be a behavior that they had produced previously in that session, but it had to be, or in other sessions, it had to be different than what they just did. So they couldn't repeat immediate behaviors. It had to be different, but it didn't have to be completely novel that they'd ever experienced. So what we did was we combined what the Kaufmans had decided they thought would be a possibility with teaching these animals this innovate behavior, or this construct, to be able to produce a different kind of behavior and see how many trials they could do it. So we chose to work with two species of dolphins, bottlenose dolphins that you see down there on your left-hand side from the Roatan Institute of Marine Sciences, and then killer whales at two different facilities, one in France and one in Texas. And we were interested in applying those four constructs from the Torrance test of creativity that had been identified by Kaufman and Kaufman to see if we could standardize our process of evaluating creativity in dolphins and apply those four different types of constructs to the behaviors that were produced by a dolphin, whether it's a bottlenose dolphin or a killer whale, under stimulus control. So they're being taught to some degree that they have to do something, but what they choose to do is on their own. So with that, we had 9 killer whales from the two facilities, San Antonio, Texas, SeaWorld of Texas. We had 5 killer whales. We had a mature female. We had 2 mature males and 2 immature females. And then at Marineland Côte d'Azur in Antibes, France, we had 4 killer whales with 1 mature female, 1 mature male, and 2 immature males. And they were all trained on the InnovateQ with basically the same goals. And they were given about a year to learn this behavior. And then we tested them with 3 sessions on testing. And I'll mention what testing included in just a second. From the behaviors that were produced during those 3 testing sessions, we then had students go through and code each and every session, because we videotaped all the sessions. And then we were evaluating what behavior was produced by the animal that was rewarded, if it was in fact a different behavior than it had previously performed in the last trial. And then we applied those creativity constructs, that fluency, flexibility, originality, and whatever the last one is, which elaboration. Thank you. And then we were looking to see whether or not that was consistent across the animals. So here on your top left, we see the InnovateQ that the trainers in Marineland in France chose to use. Over here, you see kind of a cue where the San Antonio animals were being given. So the actual gesture doesn't really matter. It's just, does the animal understand what they're being asked? And then here is an example of a test session for a killer whale in France. So this is Keho, the youngest animal. And you can see that he's doing a lot of different behaviors, whether they were vocalizations, motor movement, whole body motor movement.
He spit out his algae.
And then you can see that they gave them several different hand gestures in a row. So a hand gesture and then followed by a behavior, and then you heard a whistle, and then you saw a hand gesture followed by behavior, and then heard another whistle. And then at the end of however many hand gestures she gave that he got right, she then rewarded him with some fish. So we found that the variable reinforcement schedule seemed to increase the enthusiasm. This is sort of a side effect, a side comment, increase the enthusiasm of the animals as opposed to rewarding them after every trial they got something right. Now, this is one of the things that was different between the killer whales and the dolphins. And I'm going to go into the bottlenose dolphins in just a second. In our test sessions, basically what we did is what you saw there. The idea was we wanted to give them as many opportunities to be successful so they could do as many trials as they were interested in doing. And we called it quits when the animal produced the same behavior 3 times in a row. So if the sound that Keho made there kind of in the middle was the same sound produced multiple times in a row. So he produced it once, it was successful, it was the first time he produced it. And then if he produced it 3 more times in a row, back to back to back, then we said, okay, that's the end of the session. So sessions could have gone on for 8 trials, or they could have gone on for 100+ trials, which is what we found, interestingly enough, with our killer whales. Okay, so moving forward then to the dolphins. The dolphins, we had 12 bottlenose dolphins. They ranged in age from 6 to 30 years. So we had 5 mature males, 2 immature males, and 5 mature females. They were located at the Roatan Institute for Marine Sciences down in Roatan, Honduras. And they are under the direction of Eldon and Terry Bolton, who have been their training program coordinators and directors these years. They've been trained on the Innovate Q for quite some time. They do it intermittently. This was a project that was originally brought in early in the 2000s by Stan, and I suspect that Terry and Eldon had been working on this Innovate Q with several other animals prior to that. So they had, the males had quite a bit of experience. They often worked with the males primarily on this Q, and then we added the females across the years because we were interested in seeing if we could evaluate potentially sex differences. Their testing, they ended up with 4 sessions for their test sessions, as opposed to just the 3 with the killer whales, because we found that we wanted to have a little bit more data for those 4 sessions. And then we used the same coding process that we used for the animals with killer whales. So here's a little bit of a blurb about what it looks like in Roatan for what the dolphins received there. And then I'll talk a little bit about the differences with that, if I can get it to come back. And let me know if you can hear it.
Personality can dictate how long Terry trains a dolphin for the CREATE study. In Lenka's case, he was a quick learner and well suited to these cognitive tests.
Hold on now.
Lenka understands that Terry's hand signal, or SD, with palms up and thumbs and pointer finger touching, means that Terry is asking him to choose any behavior that he wants. As long as each sequential behavior Lenka offers is different, they'll get a fish. The scale of difference between behaviors allows for fewer or more fish per behavior.
Mouth open. Mouth open. Did you see that? Yeah. Jaw pop is what it's jaw pop. You're silly. I reinforce more heavily the more different the behavior is. If they sink down to the bottom and open their mouth, or sink to the bottom and blow bubbles, and the next behavior is an aerial, they're going to get a magnitude of reinforcement for that. Versus doing one vocal and then the next time doing just a different vocal. They'll still get rewarded because it's different, and they have to know that it's different, but it's still a vocal.
The 4 humans involved in this research only play an observational role. Lenka, the dolphin, plays the key role. He chooses what he wants to do, a leap, a vocal, or a sing. What Lenka chooses to do and how he does it is a measure of his innovation, his creativity.
Instead of us always commanding them to do something, it's us giving them the chance to choose to do something. And that's why it's so fun. And that's why I think they never leave and they don't get bored, because they get the choice. And I'm finding that that's really important to these guys, as we found in their social setting. They want to choose who they hang out with. They don't always want to be paired up with the same animal. So choice is important to them. So I think that's why they like this type of training so much, because they get to choose. Good boy. Okay, so that
What
was
would
like
you call that, Terry?
a vertical sink with a rollover.
Vertical sink rollover.
The applications for the results of this study are twofold. Historically, nonverbal children are often overlooked or viewed as not smart because intelligence tests don't often focus on nonverbal behaviors or responses. But if trainers can teach animals to show us how innovative they can be just by asking them to do something new, and scientists can present those responses as a tool to understanding cognitive function, then we may be able to apply this approach to better understanding the cognitive abilities of children who develop along a different path than typically expected. For wild populations, this research will offer insight into how dolphins might adapt to unpredictable situations or environments, and not only survive, but thrive.
Okay, so now if you want to see the full 12-minute film, that is available on the DCP website that describes a lot more about the project and some various elements of it. So that gave you a little bit of an insight of to how both the training process took place and then how the testing process took place. Now, the biggest difference in terms of testing for the bottlenose dolphins versus the killer whales was that Terry did reinforce specifically every time the animal performed a different behavior for each trial. Whereas again, the killer whales had opportunities to produce 3 or 4 behaviors with a particular, with each gesture in a row before they received reinforcement or variable types of reinforcement. So the training process is very different from the testing process, because in the training process, we wanted to make sure that the animals understood the concept before we moved on to the testing. And so with, again, the killer whales, it took them about a year to figure out the testing from a consistent standpoint, training, not the testing, from a consistent standpoint. And then for the dolphins, it took a few more years to do it because we were working on it among their other activities. And so it wasn't always consistent every time. But once we said, okay, we're going to be testing, we managed to get the majority of the training done within about a year. So similarly, time-wise in terms of that. Okay, so I could take the question from the chat. Let me see if it's relevant to this. Okay, yes, thank you. Yes, Dr. Justin Gregg was the narrator on that video. So thanks, Kel. And thank you, Justin, for putting it together. So moving forward then, this is kind of, whoops, let's see if I can come back. I just have to click the button. Okay. All right. All right. So moving into what we actually found versus dolphins versus killer whales. Okay, so with each construct, and right now we're talking about fluency, and this is how many different responses were they able to do in a test session. So remember, we have 3 test sessions for killer whales and 4 test sessions for the bottlenose dolphins. And so that's why you get to see all the fun bars everywhere. And this is basically taking however many trials an animal was able to do on its own based on the fact that they had to do 3 of the same behavior in a row at the end for us to end a session. So when we think about those sorts of things, there's a lot of variability. So as you can see with the dolphins, on average, they were able to accomplish 21 trials or 21 correct behaviors, whereas the killer whales were producing 47 trials on average or correct behaviors within a given session. Now, those sessions range for the dolphins from 5 trials that they were able to finish in a session to up to 43 trials. And the killer whales range from 8 to 135. So one of the things that we have also found is that ultimately the killer whales were more successful in terms of the number of behaviors they did correctly within a session. They had an 89% correct kind of experience as opposed to a 47%. Now, I don't put a lot of emphasis on this. I'm sharing it with you, but it's not, to me, it's not that killer whales are smarter than dolphins because they can make more solutions. A lot of it actually has to do with the training and the testing process that we use. So I think these numbers are going to be more influenced by how we trained the process and the expectations of the animals ultimately for the testing than it was for how intelligent they are. So I don't want us to walk away with a misperception that killer whales are smarter than dolphins. We can't say that with these data. They just had more trials than the dolphins did, which is probably based on the training and the testing methodology for the 2 different groups, the 2 different species. So as you can see, just as a quick overview of the pictures, there is a lot of variability among individuals. We have over here, we've got the males, which we had 7 of them based on age down to the youngest, oldest to the youngest. And then we have our females, which are not based on age, but based on kind of their I think this, yeah, general performance. And then over here by the killer whales, we have our youngest animals here on the left-hand side, followed by our males in the middle, and then our two matriarchs at the end, just to kind of give you some orientation to what we're looking at. So in general, the killer whales did pretty well, whether they were young or old or female or male. We had a little more variability with our dolphins in terms of their overall performance for how many trials they were able to get correct in a percent basis. Okay, so what I think is a little bit more telling in fluency is how many behaviors could they produce before they started repeating their behaviors. But again, we have to say this with the caveat that the killer whales were given a lot more flexibility in a sense of how many behaviors they could produce in the trial that they had been given the SD for, or the hand gesture for, versus the dolphins, because the dolphins had, I think, a more stringent criterion than the killer whales did for what was a correct response or what wasn't a correct response. So with the dolphins, you can see that on average, they're able to produce 3.4 behaviors or 1 to 12 behaviors for our range of different behaviors before they started repeating something that they had done previously. So if they had done a specific vocal, and then they had done a jump, and then they done a bubble, that would have been 3 behaviors before we saw a vocal again, and the same vocal that they had produced the first time. So dolphins are producing about 3 to 4 if we want to give it a range, but 1 to 12 is the range for behaviors before they repeated. Killer whales were able to do about 17 and a half, or somewhere between 17 and 18, and they range from 3 to 59. So again, some of the animals are kind of figuring this out. So to point out a couple of, I think, special animals, in a sense, are Kehoe is the youngest animal, male, in France. And you can see that he had a really great first session of producing a whole bunch of different behaviors, and he's our 59 animal. And then Sakari, who's one of our younger animals as well, she had the lowest option of only able to do 3 in a row before she started repeating. But you can see there's a lot of variability across the individual animals as far as how many they could do given on the session. So there's a lot of other factors that we are not controlling for, like motivation, other kinds of social interactions that might be going on, other kinds of things that they might have been working with. Now, a lot of these sessions that we had for the test sessions were generally done in the mornings, but they could have been done, somewhere at a different time of day. So they might have already had test sessions or other kinds of training sessions within their day. So there's some variability with that as well, but the majority of them were done in the morning. Over here with the dolphins, we had Ronnie as our superstar on his second day, second session that he was tested on, and he had those 12 trials that were different responses for the first 12 responses before he started repeating. So these, I think, are kind of some of the more interesting data as we start looking at the idea of fluency. So how many different responses or solutions can individuals produce? So then another category that we were interested in looking at has to do with the flexibility. So this is being able to move across different types of behaviors. So we define this in 2 different ways. We had behaviors that had to do with energy. So I'm doing a low energy behavior, like for a human, this might be like a blink, or maybe I lift my shoulder a little bit, but I'm not putting a lot of effort. It's not taking most of my body or energy to produce that behavior. For a dolphin, it might be a vocal, or I raise my pec fin up. Now, if I move my pec fin or I wave my hand, I'm moving into more of a moderate energy behavior. And then if I'm jumping while I'm doing these things, or just jumping, I'm in a high energy behavior. So swim behavior is definitely using the body, but I can swim at different speeds. And so moderate behavior would be swimming at a slow to normal pace, whereas a high energy swim would be a fast swim where you start to see white water and those sorts of things. So hopefully that gives you a little bit of an idea of how energy was. So the key things here is all of those levels. So the L stands for low energy, the M stands for moderate energy, and the H stands for high energy. We also looked at times at which they did kind of compound behaviors or sequence behaviors, where they had two low energy behaviors. So that would be the L plus L right here, that number 4, or two moderate energy behaviors. And then down over here on the farther side is where you start to see the combinations of a low plus a moderate behavior performed at the same time. And then that 10 is going to be all the activity levels at the same time. So a low, a medium, and a high behavior were performed at the same time or in close sequence to one another within that trial. So as you can see, both dolphins species, the bottlenose and the killer whales, are pretty similar in their preferences, if you will, where they're tending to perform those low and moderate behaviors more frequently than anything else. And high behaviors are part of what they do produce. They just don't produce them as frequently. So you see that the dolphins are a little bit higher in their percentages or their proportions of how often they're producing that. And the killer whales are showing a little bit more variability in some of their preferences. And as you can see, those wonderful error bars are really wide in terms of what the killer whales are choosing to do. So are they able to be flexible? They are, but there do seem to be some restraints or constraints about how flexible they are and the energy levels that they're producing. So they're smart in the way that if I can earn a fish for the same thing of vocalizing as I could if I went and did an aerial, then I might conserve my energy and just offer the vocals from different directions. So if we want to think about strategically, you know, we would have loved to have seen higher high energy behaviors or combination behaviors, but maybe these animals are really good about figuring out what their contingencies are and why not produce the least amount of effort and get the most reward for it. So I'd say that's pretty smart behavior, if we will. Now, another idea for flexibility had to do with the types of behaviors they engaged in. So that's where we start thinking about the locomotor behavior or the vocal behavior or the water behaviors, which are bubbles and squirts and other sorts of fun water things that they can do. And so again, you can see that the dolphins and the killer whales are, again, very similar. They're choosing to engage in locomotor behaviors, most of which are part of their behavioral repertoire that they've already been trained on. So they're very familiar behaviors, not necessarily novel behaviors. They also produce a lot of vocalizations, and then they do seem to put combinations of two locomotor behaviors together. So they might do a peck wave while swimming or moving their head from side to side while they are bobbing up and down or spinning in a circle. So they are showing similar kinds of patterns in terms of what sorts of categories of behaviors they're engaging in. One thing to note kind of just quickly, the dolphins combined locomotor behaviors with vocal behaviors some, and the same with locomotor behaviors with water. But you can see that the killer whales are doing a little bit more of it. Don't know if any of this is statistically significant. We didn't compare those sorts of things. This is just more of a descriptive experience. Okay, so far it looks like we've been able to at least code behaviors that they produce under stimulus control for the kinds of behaviors, whether it's energy or the classes of behaviors they show. And there is some flexibility in the behaviors that they are giving to us in a given session across multiple sessions. Now, the key thing here for elaboration is how many different things can you do at one time? Whether that is producing a sequence of behaviors or producing behaviors at the same time. So as you can see, both the killer whales and the bottlenose dolphins are very much about performing single behaviors, and that tends to be what the majority of their behaviors were. And with the killer whales, you can kind of see what the males are doing. Uh-oh. I always have fun with Max. I got it back. With the killer whales, you can see that the males and females are doing things a little bit differently, but not very much. And then those sequenced behaviors and those simultaneous behaviors are not happening very frequently. They do happen, the sequence behaviors did seem to happen about the same amount of time as the sequence behaviors within the dolphins. So there is some similarity there. But what we see for the killer whales is that they are showing slightly more simultaneous behaviors than the dolphins are. And I think, again, this is not because killer whales are more complex and more intelligent. It's more about what they were allowed to do within the testing paradigm. They were able to put together more combination behaviors to be considered correct than the dolphins were. The dolphins were expected to produce a single behavior most of the time, but they did start doing those compound or those simultaneous behaviors, which was pretty neat to see as they were starting to emerge. And finally, when we start thinking about the originality piece, this is truly the question. How many novel behaviors did they produce across the testing, across the training? So across testing, 3 males and 1 female produced each a behavior that had never been trained before for the bottlenose dolphins. And then for the killer whales, we had 4 of our 9, 2 males and 2 females that also produced an individual behavior during the testing that was never trained. Now, they did produce some other behaviors during training that were considered new to their repertoire that were not trained by the trainers. But during testing, they didn't produce them very often. So they are able, as we had already known from Karen prior, to be able to produce completely novel behaviors under this paradigm, but it doesn't seem to be something they do regularly or consistently. Now, whether that's because they weren't reinforced for doing that, or if it was something that they don't think about and they do every once in a while, we don't know the answer to that. But that would be something that, future people could try to take a look at and see a little bit more with. Now, one of the things that we did go do for the bottlenose dolphins that we did not do for the killer whales was we gave them a ranking to see if their performance on each one of these constructs kind of gave us an overall holistic view of how creative is the dolphin, and are they consistently creative in each of these constructs that we were evaluating. So we evaluated the fluency construct, the flexibility construct, and originality construct in terms of rank orders. We excluded the elaboration construct because we felt that in the dolphin side of the house, the bottlenose dolphin side of the house, that the training criterion and the testing criterion was too stringent, and it didn't allow for a lot of elaboration if they in fact were able to sequence behaviors together or add a compound responses or simultaneous responses. So we removed that from the bottlenose dolphins in this particular analysis. And so what I just want to kind of highlight to you, I'm not going to go through all the scary numbers and the data points here, is that when we looked at what their overall success rate was in terms of fluency. So those animals that were able to produce more responses correctly within a session, or those animals that were able to produce multiple different responses in a row before they started repeating, you can see that there's some variability about where the animals are falling. So Han was number 1 on this fluency measure, but he's number 7 on the number of behaviors before he started repeating. Ronnie, you can see, holds the 2nd position in both types of fluency. Bill is here at 3rd, but then he's sort of 6th here. And then if we kind of jump to the bottom here, we can see that Tilly and Bailey and Linka are covering those bottom parts on this measure, but Gracie, Linka, and Richie are covering the bottom parts in this measure. So this is kind of how we were looking at it. Was based on their performance of correct responses and how many they could do in a row on average for fluency. And then we kind of hop over to flexibility here. And this is these are the 2 flexibility scores where we looked at the high, low, medium scores of energy and those vocalizations versus the motor behaviors versus the bubble behaviors. And again, if you kind of look at the top 4, we can see that French is number 1 on his flexibility and energy, but Han, Bill, and Champ come on into play here. And if we look over here for what kinds of behaviors they're producing, Maury happens to be at the top, and that's one of our females, but then there's Han, Champ, and Bill with a little bit of movement there. So when we start thinking about where these animals are falling at the top of their rankings or at the bottom, we can start to see that they do seem to perform sort of similarly based on the way we've operationally defined or started looking at each construct. And then over here with our originality piece of it, you can see that in terms of our definitions, that if we're looking at behaviors that were never performed by any other animal, so it could have been novel, or it could have just been a behavior that no other animal performed, but is part of their behavioral repertoire, we can see that Han is, so these are not ranked, these are just their actual numbers. But we can see that Han has 6 of those behaviors, whereas Bailey has no behaviors that she performed by herself, and nobody else happened to have those same behaviors in theirs. So we had several different definitions of originality, and you're more than welcome to read the paper to look at them a little bit more, but I wanted to kind of go through a bit of those. So here's what the overall rankings, dang it, I did it again. That's all good. Here are the overall rankings of who landed first, who landed second, who landed third, and who landed at the bottom here. So Han, as we saw, was pretty high on most of the rankings that we did with him. He came in first as what we consider the most creative bottlenose dolphins because he had the highest rankings across all 3 constructs that we were looking at. Ronnie came in second and Bill came in third. At the bottom, so if you remember, Lenka was highlighted in the video that I shared with you from Roatan Institute, and he was highlighted in the video, but he came in dead last. But for Lenka's point of view, this was a relatively new behavior for him, and he hadn't been working on it as long as Han, Ronnie, Bill had been working on it. But I would also like to point out Champ and Lenka are very similar in age, and Champ was a superstar. So there is something, while there are things having to do with age, and there are things maybe dealing with sex differences, we're not positive about that. Definitely individual differences are coming into play. So while prior history is important for this and their experience with it, there is something to go with that individual personality and the way that they think about what's new, what have I have not done before, and maybe strategically performing in this particular task, maybe coming into play with some of the stuff that we're seeing. So to wrap up and kind of get us to a point where we can ask for some questions, and thank y'all for staying with me for what turned out to be a little longer than I expected, but that's okay. Are delphinids, in this case, bottlenose dolphins and killer whales, creative? Yes, absolutely. I think that we've been able to show that, and we've been able to reliably demonstrate that through coding behaviors that were produced and in humans looking at it. But I think it depends on how they're trained and what the ultimate goals are for a test session or for the trainers. As Kaufman and Kaufman suggested, could we apply the Torrance test of creativity to the behaviors that are produced by animals that are not humans? Yes, it seems like we can do that, and we can do it reliably. But we do know that there is a lot of individual variability that does seem to be determined to some degree by practice, but also by whatever their innate predispositions are. And I think that's one of the key points that I really want to think about when I think about the natural history of these animals, right? So if we think about dolphins and different populations, let's take Shark Bay, for example, where there is several lines, matrilineal lines of dolphins, but only one line or maybe 2 lines are able to do different foraging techniques. That seems to not be something that is necessarily shared across the other matrilineal lines or populations, whether they are observationally gifted at learning or just something that they're doing innately through their genetic lineages. When we think about killer whales and their novel solutions, I think of the transient animals across the world and the different ecotypes that have different solutions when they're trying to hunt for seals or hunt for different types of fish or to hunt for other sorts of mammals. And they come up with these novel, amazing coordinated efforts to be able to beach themselves or to make an ice floe flip over to pull a seal off on the other side. But then you compare that and contrast that to the southern resident whales who apparently don't know how to eat anything other than the particular salmon that they prefer. So when you think about the constraints of the individual animals or the species or the population, I think there's a lot that goes into this, that it really does depend on reinforcement history, which is what studies like this can demonstrate for us. And then from the other side of the house, being able to do studies like this in managed care is super important, not only for helping us understand what's going on in the natural habitat, but for the animals and the trainers themselves that are working with these animals on a daily basis. This is a fun task, and I am more than happy to say it that way. The animals get excited, the trainers get excited, the people who are watching the session get excited, and it's super awesome to see an animal do something in an arbitrary way, it seems like, but in this very novel and ambiguous construct, that they are coming up with the stuff on their own. And so from my perspective, a task like this and this kind of study, whether it's done for, a cognitive test purpose or just for fun, is an opportunity for these animals to have choice and control over their world in many, many different ways. So I think I'm going to end with that and say thank you very much for all of our undergraduate assistants and our other graduate assistants that have helped us collect the data, code the data, process the data, and then obviously to our institutions that have helped us with all of this, and to DCP for the opportunity to share it with y'all. So thank you very much.
Thank you so much, Heather. I am going to sneak in some wrap-up slides while I still have our audience, whether you're listening live or to the recording. If this was your 70th webinar with us, thank you for joining. If it was your first and you want to know where there are more, you can go straight to DCP's website, dolphincommunicationproject.org. Just look under that Knowledge Hub and you will find webinars. If you prefer YouTube or Vimeo, you're in luck because they're there too. And this was a deep dive. So you saw Dr. Hill didn't shy away from numbers and charts and things like that. It's a little longer. We also have dolphin lessons, which are geared more towards elementary students and the young at heart. So you can grab those. There are some fun how to draw ones in particular are my favorites. And then if you still need more in your life, be sure to get episodes of our podcast, The Dolphin Pod, wherever you listen. And of course, DCP is a nonprofit, so I am contractually obligated to remind you how you can support us. You can become a dolphin protector, which is a new kit that we offer, kind of pledge that you're going to protect dolphins, get a certificate, information sheets, things like that. You can become a member, you can buy swag, you can join Kathleen in the field, use our promo code at Stream to Sea, headed into the summer, get some actually reef safe sunscreen and other products, and just stay in touch, follow us online, share posts, keep tabs on us, and we look forward to hearing from you. So with that, we do have some questions. I'm never sure what order to ask things in, but one of the later questions will go first. Will this study continue, or are you kind of done with it?
Great question. We always want it to continue, but I think at this point we're taking a break from it. One thing I will say that we have seen that I need to talk to Terry about is that she has continued training the innovate behavior with the bottlenose dolphins down at RIMS. And the males that she's been working with primarily are actually showing very similar kinds of complex behaviors that the killer whales were showing. So, so one time I would really love to go back and actually do another testing session with the males sooner rather than later, so that we could code it and show, yep, they too can do the same complexity and the combination behaviors that the killer whales were able to do when they were tested. So so right now that's kind of where we are. We do have, actually, I will give you a little bit of a heads up. We do have 2 other papers that we're working on, one that's under review and one that we are hoping to get completed this summer, that actually is looking at the effects of reinforcement history on the during training on the testing. So the killer whales in France were actually given 12 test sessions, not just the 3 that we had requested originally. They were very excited by the project, and so they went on and did a whole bunch of other stuff. And the first 6 sessions were done, well, the 12 sessions were done slightly differently depending on the animal, because they that each animal informed what was happening in terms of the testing. So we had some opportunities to evaluate what happens when you do the same kind of reinforcement for all trials versus variable reinforcement for all trials versus the first 6 sessions that had consistent reinforcement for the trials versus variable reinforcement for the last 6 sessions. So we have that paper that's currently under review to kind of give us an idea. There does seem to be an impact of the variability that was given in reinforcement during training. And actually, this is more so during testing. During testing, that changed the outcome of what the animals did in terms of their creativity. That's what we're trying to say. And then our other paper that's forthcoming is looking at, did their reinforcement history during training influence the behaviors that we saw during testing? And the quick answer to that is no. So that's kind of where our future is headed in terms of the next couple of things for this particular study, but we're not collecting any more data anytime soon.
Always then what do you do with all the data? And you need to breathe long enough to actually analyze it and write it up.
You got it. Exactly. We've been very busy for a while.
This came in as a comment, not a specific question, but I thought you might want to chime in. How does this methodology, is it actually measuring the ability of an animal to learn what humans are saying are different behaviors versus their actual understanding of a novel behavior?
Yeah, I think that's a really great question, and something that I think we have wrestled with for a while now, and trying to understand what is it. Obviously, when we are evaluating behaviors, there's always the human perspective that's coming into play with what's being produced and how do you categorize it. I would say that the answer is probably, so here's my wishy-washy answer. It's probably both. I would argue that the animals do, as they are given lots of different opportunities. So a couple of pieces of evidence. They're given lots of opportunities to produce a variety of behaviors with the same hand gesture, right? So there's no specific behavior associated with that hand gesture other than the concept that you need to do something different. So I do think that they are representing a construct or a concept with that idea. My other evidence for that is we are not seeing them produce the same sequence of behaviors each time they're given. So if we start a session, you're not getting one vocal, and then you're getting the head, shake, and then you get the tongue out, and then you get the dive. That is not something that we see the animals do across the board. They don't start in a sequence and go with a particular, set of behaviors until they're done. Now, did that happen in the past? It did. It was something that they did do early in training, where they did to seem to kind of have a rhythm of what behaviors they go through first, and then they start producing those different behaviors. But I think across the board, there was no test session that had the exact same first 4 behaviors or 5 behaviors or 6 behaviors, whatever number we wanted to work with. So I think those pieces of evidence help us understand that, yes, the animals do understand the construct of what's being asked of them, which is do something different. Now, does that mean that they understand I'm being creative and I'm doing something innovative? No, I think that's probably providing too much credit in a sense to them in terms of that option. When we think about foraging innovation, it's usually in my experience, it seems to be a variation of a theme that they have done before. So can we apply it to a new niche of food? So instead of using a sponge on my rostrum, I'm going to use a shell on my rostrum. And I might be doing that to 2 different types of fish, but I'm using the same variation of a theme of covering my rostrum up with something for some reason. So I don't know if we can answer that the animals know that they're being or understand that they're being creative, but I do think from their behavior that they are producing, they do understand the concept of do something you haven't done before. And then, of course, there will always be the human bias in terms of what we see the animals doing, which is one of the reasons why we tried to be really careful with having reliable coders and then having reliability assessed for both measures, whether it was the coding, what the behavior was that was produced, or what category we decided to put it in when we went and coded it for the 4 constructs. So hopefully that makes sense and answers the question or the comment that was made.
Thank you. Were the animals always tested alone? And if they were other animals in proximity to watch them?
Excellent question. The killer whales were all tested alone. So they were with their trainer individually. The killer whales in San Antonio had other killer whales present, but were under control. So yes, they could have potentially watched what they did, but they were kept occupied. So they were engaged in a different training session. So they weren't watching what the other animals were producing, I don't believe. In the dolphin side of the house, the bottlenose dolphin side of the house, the males were always tested alone, but there were opportunities for the males to watch from underwater, from behind, because they shared the pool space and the pen space there in the lagoon area. And then the females were generally tested in the lagoon, and they often had calves. So they were sometimes very distracted and had many calves to pay attention to. But I would say generally we worked pretty, we had a concerted effort to make sure that the individual animals were trained and tested individually, and the other animals were not, when they were tested, they were not within close proximity of the ones that we were testing at the time that we tested them.
Thank you. The sessions that you referred to, particularly in the graph section, were those done back to back? Were those spaced out over lots of time? What was that
Great
like?
question. Right. They were done, we did one test session a day, and sometimes it was 1 or 2 days in a row, or it was a test session with a day in between and then another test session. So it depended on the facility, and it depended on what was going on. But we definitely, they were spaced out. They were not done in the same day, and yeah, within the season of it. Yep.
Yeah. And then I think we had one more question, is that whether or not any behavioral changes were observed just anecdotally immediately following sessions.
So I wish we had been able to do this and actually evaluated it. For the bottlenose dolphins, we were present for the behavior, what was going on afterwards, and I didn't notice anything different after a training session or a test session. So after a test session for this activity, I didn't notice anything of difference. The same, we were not present for after we finished the testing sessions for the killer whales in San Antonio. We didn't stay around to see what sorts of things were happening as from an observer point of view or a researcher point of view. And then the same thing in the killer whales in France. We didn't stay, we were not present for those. Those were all videotaped by the training staff in France. Anecdotally, what trainers did share with us is not so much associated with the testing sessions themselves, but more so the behavior. And what many of them did describe, and this is true of whether it's the dolphins, and you heard Terry say it at the end of the video, none of the dolphins ever left. They always were excited to be there, and they continued to persist despite making mistakes. That was the same kind of response that we heard from the killer whale trainers as well. And even more so, the killer whale trainers often ended up using the Innovate cue to get the animals to become engaged. So if they were noticing that animals were disengaging in a training session or in a presentation or a show of some kind, they would sometimes pull that behavior out and ask them to innovate. And then the way they describe it is the animals became extremely animated, were very excited, and became much more engaged following doing a few SDs or hand signals for that particular behavior. So we didn't see, that's sort of our kind of one of our future goals is, will they take this innovate behavior and apply it to, new problems and see if we can use it in different ways? Our colleague, Dr. Lauren Highfill has done a little bit of that with some dogs and puzzle solving program within her companion animal science, citizen science stuff. So I'd encourage you to look up Dr. Highfill and her dog studies. But yeah, that would be sort of some next steps if we could do it with the killer whales and the dolphins.
Awesome. Just typing her name into the chat so people can jot it down if they want. Thank you all so much. Thank you to our live listeners for your great questions. And most of all, thank you to Heather. We really, really appreciate your time, your willingness to answer those questions at the end. And we hope that we see everyone at another Dolphin Communication Project webinar sometime soon. Thanks, everyone.
Y'all appreciate it. Bye.
Bye.